Welcome to Basic Data Analysis using SPSS. My name is B. Kaulu. My presentation is summarized using the outline here. I'll talk about the target audience for this presentation. I'll highlight the software needed, and then we'll talk about the basic requirements for reporting, and so we'll run through sample profile and demographics, correlation analysis, regression analysis, which sums up what you need to present for doing basic analysis. The target audience for this presentation is master's and bachelor students, and the background for doing this video is that I've been examining and supervising students for the past 6 or so years, and one of the biggest reasons why students fail to pass their research projects is because of inadequate data analysis. And so this video tries to give some minimum reporting requirements when you do your master's or bachelor's degree research project. So there are many possible ways you can do your data analysis, but this is one of the simplest and recommended ways of doing data analysis. So minimum, when you present your results, we expect to see, number one, your sample profile. Who are the people that you, if you did, especially in the social sciences, you probably did your research using a sample of people. Who are the people that you looked at? What are their demographics in terms of the age, the gender, and so on and so forth. Number two, we expect to see some validity and reliability tests. So I'll expand on this where we're going. And then number three, we expect to see you test your hypothesis. Many times we see people presenting hypotheses, but then when you go check the results, they do not test the hypothesis or do not test them appropriately. And so if there are no hypothesis tests results, then the project cannot pass. And so in this video, I'm going to talk about 2 ways in which you can test hypothesis, which are correlation and regression. The software that you need to follow along this presentation are Google Forms questionnaire. So I'm presuming that by this time you have collected your data and you collected it using a questionnaire, and I'm using Google Forms, and I hope that you have it at that stage as well. Second thing you need is Excel. We'll be working with Excel quite a bit. We'll clean the data in Excel before we move it into SPSS, and then finally we'll present the results in Word. To start with, I'm going to work with a very simple example of a study. Imagine I'm looking at the effect of 3 variables: tax awareness, tax fairness, and tax complexity, and how these 3 variables affect tax compliance. So by this time I have 3 independent variables and 1 dependent variable. So again, we see people struggling a lot with this, but I'm hoping by this time you fully understand how to arrive at this point. So I'm presuming you've already arrived at this point. So to give a feel of where I got my questionnaire from, this is a study I did in 2021. It was looking at the determinants of tax evasion intentions using the theory of planned behavior. So I'm presuming you already know how to come up with a questionnaire, but in this study I had a number of questions which are at the bottom here. So I had a number of questions for my questionnaire, and these included questions on tax evasion intentions, egoism, tax awareness, and so on. So we're going to use some of these variables in the study. And so what I have is an online questionnaire, and in this online questionnaire we had several questions, and it started with our demographic variables there. So it started with our demographic variables. First we asked our respondents to consent, we asked about their gender, we asked about their age, and then we went on to ask them on a Likert scale. So we had a number of questions on a Likert scale, which included statements like, I think I should honestly declare my taxes, I think taxpayers should not underreport their liabilities, I think I will not evade tax, and so on. And what we need to do now is go ahead, and we've collected 157 responses, so we'll go ahead and download the responses. To download them, you just click responses, and I'm not running through how you create these responses and how you create the questionnaire, because I'm presuming you already have it by now. So Google Forms does some analysis for you, and I've seen people as well copy these and paste them into their report. I think it should be okay for some demographic variables like this one. So here you have your age. It's possible for you to copy your age variable there and paste it. So this one you could copy and paste in your Word document, but I would prefer we do it through SPSS so that we get some robust analysis. So you click on responses. When you're on responses, you then click on view in sheets. So Google will open up in a different tab, and from there you can go ahead and download your responses. So you just wait for it to fully load. Once it's fully loaded, you can go ahead and download. So it's still loading, just wait for it to completely load. So once it's done, you can then click File, then come down to Download, and then Excel. I like downloading in Excel. You can download them in any of the other formats, but we'll use Excel, so I'm downloading. And once you click Download, it will go ahead and start downloading at the bottom there, and then it will complete. Once it's done, you can go ahead and open your Downloads folder. So I have my Downloads folder, and there it is. I'll copy it, and I'm going to go and paste it in the folder where I want to work from. So once I copy it, I'll paste it in the folder I want to work from, and it's still loading. Once it's done, we can go ahead and double click it. So once you double click it, it will open in a format like this. So you have all these things here, and you need to, work through these. What I normally do is I'll go to the bottom here and right click so that I make a copy. So I'll say move or copy, and then when this opens, I'll say create a copy, and then click move to end, and then click OK. When I do that, it will create an extra copy, and I will rename that and say cleaned. It's a cleaned version that I'll start working with. So in the cleaned version, you're going to notice I have a timestamp here. It's okay, I can just leave it. We had asked respondents to agree to fill in the questionnaire freely, so I'm going to leave that as it is. And then there's all these variables, so I'll just leave those variables as they are. I'm not going to change anything. The variable names, these are the questions, so I'll leave them as they are. but I'm going to try and work through this to just help Excel clean it up a bit before we move the data to SPSS. So I'm going to select all these where we were asking people to confirm on a Likert scale. I'll select all of them. All the way to the end and make sure that all of them are selected. We had 157 responses, so I've selected all of them. Once I select all of them, I will either click Ctrl F, or I will go up here and say find, and then I'll say replace. Once this opens, I will just rub everything in there. I must have been replacing some material earlier on, and then I'm going to search through my Excel spreadsheet and say find strongly agree, and I want that to be replaced with a 5. So everywhere where there's strongly agree, let it replace with a 5. So replace all, and Excel will go ahead and tell me that it has replaced 460 replacements. Then I'll go back and say go back through the spreadsheet and check for strongly disagree, replace that with a 1. When I say replace all, it will go ahead and has made 187 replacements. I'll go back and say everywhere where there is disagree, so disagree should be replaced with a 2. Replace all. It will go right ahead and tell me that it has done 691 replacements, and then I'll go ahead and say anywhere where there's agree, I need a 4. Replace all. It has made 1078 replacements. Finally, I will go ahead and say where there's neutral, let there be a 3. Replace all. It has gone ahead and made 724 replacements, and I can do a quick check through my data set to see if there's any issues, so I can tell that everything was done appropriately. So now my data is in numbers, and SPSS will be able to interpret it appropriately. It's also possible to edit some of these, but I'm just going to leave them as they are for now. Once you're done, make sure you've saved. So I'll go up there and save. So my Excel file is named Survey on Taxation in Zambia, Lesson 1, and I'm interested in this clean folder. It's a good idea to move it to the first tab there, as we'll see. So I'll save it again, and then I'm going to go ahead and open SPSS. So your SPSS would open something like this. I'm presuming you know how you've installed SPSS and you know how to use it, and so you simply open it like this. So once SPSS is open, you go to File, it's gonna take a bit of time, probably because there are a lot of software running. File, and then open data. So we'll go to data. Once data is opened, you're going to see this, so the file picker. So just go to the location where your document is saved. For me, it's in drive D. Next, it's in projects. Okay, so mine is in that file. I've navigated to the file where it is. If you don't want to navigate like that, you could simply save your data in your downloads, and then you can work from there. I know it's in this folder, but then notice there it's SPSS is looking for SPSS files which are .sav files, but my file is an Excel file, so I'm going to change that to Excel. and it will show me the Excel files in that folder. So just make sure you change that for it to detect. So then I'll select my Excel file and click OK or open. Once I click open, SPSS will go ahead and start trying to load the file. That takes a bit of time. Okay, so once that is opened, you're going to notice here my form is selected. It's also selected that tab that said cleaned. There's also the other tab, but we're interested in cleaned. And then read variable names from the first row. Make sure that is selected. That's because when you go to your Excel file, it reads that first row as your variable names, and it has selected the cleaned file there, or cleaned tab. So we can go right ahead if everything is okay and say okay, and SPSS will go ahead and collect all the responses. So it has given us that output to show us that this file has been obtained. And once you minimize that, you can go back to your data set, and you're going to find that your data has been uploaded into SPSS. So what I would normally want to do at this point is just to go ahead and save my work. So I'll go and say save as, and I'm going to call this tax study. I'll call it lesson, and then I'll click save. So it's already in the lessons folder that I want to save in, but you can navigate to where you want to save it. I'm going to go ahead and click save. So once it's saved, I can then go ahead. Again, I'm presuming that you are comfortable working with SPSS at this point, but if you do not know how to work with it, this is the data view that we're looking at, where we are seeing the data as we see it in SPSS, in Excel. But there's also the variable view here. The variable view is where you see the variables. Now, as you can see on top here, all these variables have got these very long names that do not make sense. So we can make that better by coming to the variable view. And when we come to the variable view, we can expand this. And I know the way I asked the questions in Excel, in the original questionnaire, that this question up to there we're asking for tax complexity, and I can call that TC1, TC2. So all these questions we're asking questions to do with tax complexity. So TC3, TC4, TC5, all the way up to TC6. So all these questions were asking tax complexity questions, and I'm happy with that. So after changing those, I'll come here, and you're going to notice I now have TC1, TC2, all the way up to TC6, and the other variables are not yet changed. So we go ahead and change the rest of them. So there's FN1, which is tax fairness. All the way up to the last one. So I said TC is tax complexity, but actually those were questions asking on tax compliance. So I think taxpayers should not report I think taxpayers should not underreport their taxes. I will not evade paying taxes. So those are tax compliance questions. Tax complexity questions are these ones at the bottom. So those will be measured by, we'll use CP. So CP1 to talk about complexity. So CP2, CP4, and finally CP5. Okay, then the last set of questions we had were awareness questions. So tax awareness 1, tax awareness 2, tax awareness 3. So I'm just typing and clicking enter. Tax awareness 4 and tax awareness 5. So this way, once we are done, we can come back here and you can now see that this looks much better. All the way to the end, the variables have been changed. I could also reduce the sizes here, but maybe let's just leave it as it is. So we have AW for awareness and all those variables. So once I'm done, also I can go back. You can see here the variables are not looking okay, so I can come back here and scroll up. The first one was asking people for consent, so I can change that to consent. The next one was asking for their gender, so I'll enter gender here. Please note that variable names can only be one word, no spaces, and they can be letters or numbers, as you can see here, but there should be no spaces. So here age, so we'll just put age because it's asking them how old they are. And then marital status, so marital. You can also have underscore status, so marital status. So once you're done, when you come back here, you will notice time, consent, gender, age, and marital status has come up there, and so it's looking all much better. We can click save to just make sure everything is okay. So now we are ready for analysis. Before we analyze, also we must make sure that all the variables are just okay, but I think this is okay, so we can go ahead and begin with the analysis. So now that we have cleaned our data and it's ready for analysis, we need to go back to our objectives and think about what exactly we are doing in the analysis. So to think about the objectives of the study and what we're doing in the analysis, it's always a good idea to look at your diagram there, your conceptual model. So in our model, we are hypothesizing that tax awareness has either a relationship or an effect or both on tax compliance. Tax fairness has an effect, that's H2, on tax compliance, and tax complexity has an effect or relationship with tax compliance. Before we actually go ahead and do that analysis, remember we've got so many questions. We are making an inference about the population based on the sample. So to begin with, we want to describe the sample. Before we actually do the analysis, we want to describe the sample. So we'll give the frequencies, the cumulative frequencies, so that the reader can have a feel of the sample profile that we are looking at. And we try to present that using APA format. APA format is just one of the reporting standards that's there. You can actually search for the APA manual for presentation of data to just read, but it's a very big book. So I'll just go ahead and try and present the sample profile. So to do our sample profile, I just want to give you a picture of how a sample profile looks like based on that study that I showed you. So let's just search there, say sample. Okay, so this is me presenting the sample profile in the earlier study I did, and it's in table 2. So basically table 2 shows the sample profile, and as you can see here, there's the age categorized into the different age ranges, there's gender, there's marital status, and so on. So to go ahead with the sample profile, what we need to do is go ahead and we are going to target age, gender, and marital status. When I go to age in SPSS, what you're going to notice is that the age is actually here. The edge is continuous, but in the profiles there we are seeing that the edge is grouped into the different categories. So you can create the edge categories as follows. In fact, we need to do more cleaning on the data, so I'm going to go ahead and just say I'm going to create a new variable called edge group. So to create a new variable, what you need to do is say transform compute variable, actually not compute variable, transform record in same variable means you are going to change a variable and put the data into the same variable, but we're going to record in different variables. So record in different variable. So what we want to do is get our edge. Sometimes you find that SPSS may be giving you all these long words still, so you can right click and just say display variable names. That way it's smaller and you can easily see them. So I'm interested in getting edge, so I'll get edge and drag it here. Another way is, instead of dragging, you could click on it and click here so that it comes. So the new variable I want is going to be called edge group, and I can label it as edge group. Notice that when naming the variable I put an underscore because a variable name should not have spaces, but for the label I didn't leave a space. So once you do that, you can click change, and a variable is going to be created in the data set called edge group at the end here. So we can go ahead and say it hasn't been created, but we need to do a bit more. So we can go ahead and say all the new values, we click that. Then we are going to say in the range from the range lowest to the edge of, if we look at our data set there, edge of, I know we started from the edge of 18 in our data, but I'm just going to begin from the edge of 0 all the way to edge of 20, and I'll go back there and say range lowest through to 20. I want that to be assigned a value of 1, and I'm going to say add. Then from the edge range of 21 through to the edge range of 30, I need that to be assigned a value of 2. I'm going to add. From the edge range of 31 through to the edge range of 40, I need that to be assigned a value of 4. I'm going to add. Actually, you can, if I make a mistake like here, I need to just click there and I can remove. Okay, I've removed it, and then I'll do it again. So I meant from the edge range of 31 to the edge range of 40, I need that to be assigned a value of 3. You add. From the edge range of 41 through to the edge range of 50, I need that to be assigned a value of 4. So we add. So that's 1, 2, 3, 4. And then from edge range of 51 value through the highest value, I need that to be assigned a value of 5. So to go ahead and assign edges 0 to 20 as 1, edges 21 to 30 as 2, edges 31 to 40, and so on and so forth. So I'll click continue. Once I do that, it will go back there. We haven't completed the change. Notice what will happen there. Finally, I'll click OK, and once I click OK, of course the output will come through and it's going to tell me that it has created edge group, and those are the instructions we gave it. I'll just minimize that and we'll see edge group has been added here with values 1 to 5. Now we need to tell SPSS to say these values mean the following. So to tell it, we'll go to variable view. I clicked data view to come here, but I'll come to variable view. On variable view, we'll go where age group is, and we will now give instructions on the values in the values column there. So we'll say where there is a 1, that should be taken, the label should be below 20 years. Actually, that's 20 years and below 21 years, below 21 years. Where there's a 2, it should read as, where there's a 2, it should read as 21 to 30 years. Where there's a 3, it should read as 31 to 40 years. Where there's a 4, it should read as 41 to 50 years of age. And where there is a 5, it should read as above 50 years of age. So once I do that and click OK, Excel goes ahead and has SPSS goes ahead and has assigned those values. We can just come back here and check. To check if the change has been made, you can click there on labels. Once you click on it, you're going to see that the ones will be changing to the appropriate years, and once you click that, it will go back, so you can go between that. So now we have grouped the ages, and we can go ahead and do the analysis to check the age range as well as the gender and marital status. So to go ahead and do the descriptive statistics, we can just go to analyze descriptive statistics, and I'll just do basic frequencies. For the frequencies, again, it comes up with a lot of variables. I'll right click and just display the variable names. So right click, then display variable names, and I'm interested in not age, but I'm interested in the age group, so I'll move that here. Then I'm also interested in gender, I'll move that here. I'm interested in marital status, I'll move that here. And then you can check for statistics, you can have all those statistics. I'm not interested in those statistics, I just want basic frequencies. So I'm just interested in the frequencies, so I won't do anything else there. I'll just click OK and display frequency tables. Once I do that, SPSS will go ahead and do the analysis. It says running at the bottom there, so it's still running, and when it's done, it will say processor is ready. So these are the results. Now you don't just go ahead and pick them and start dumping them into your document. What you want to do is go ahead and copy them into Excel. So at this point, I'll get the age group, right click and copy, and then I will come down to Excel, and in Excel I'll click there to add another tab, and then I'll rename this and just say results. So I'll get that and paste it. Okay, then I'll go back. So in fact, let me rename this as descriptives. So I'll copy that and paste, and then I'll come back to SPSS and copy the table for gender and come back and paste it. So paste, and then I'm going to go back to the table and copy marital status and come back to Excel and paste it. So now I can delete this, and I know that this table is for gender, so where there's valid there, I'll just say gender, and then I know this is age group, and I'm just going to delete that as well. You will notice that these are frequencies, so this is not needed. I can delete that. This is marital status, so I'll say marital status, and then I'm going to go ahead and delete these. One trick when doing analysis is that you do not, so first of all, you will notice that these were now frequencies, these are percentages, these are valid percent, and these are cumulative percent. One thing you'll notice is that you do not need valid percent, because you want to only present things that you're going to interpret. So in this case, we do not have any missing variables, and which is the case when you do analysis using an online questionnaire like this. So we can delete that, and the rest of it looks just okay. Now we won't just go and copy and paste this in Word. We just need to make it in proper APA format. So I'll select everything, no borders, then I am going to increase this, and then I'm going to draw borders with a thick line style. In APA format, you do not have lines throughout, so I'm just going to have a line at the top and right at the bottom, and I'm going to, these were merged, so I'm going to undo the merge and center, maybe no, cancel and undo. So I think this is okay. Let's see, maybe let's just select everything, change the font to 12, change the font to Arial, no, not Arial, let's use Times New Roman, which is the standard for reporting for most academic literature. So we can then change this, delete this. The number of decimal places, and let's increase that to 1 decimal place. Okay, just 1 decimal place, and maybe we can even center that. So once we are done with that, we can simply copy this and go and paste it in our Word document. So as we paste in our Word document, you will notice here you write your chapter and go ahead and say introduction. Tell the reader that this chapter presents the results. It begins by summarizing the sample profile, which we are summarizing here, which is followed by validity and reliability tests, which is followed by hypothesis tests. So I'm going to go ahead and paste my data, my table there. So I'm going to paste it using that one. Once it's pasted, I can click there, right click, and then fit to window so that it fits nicely, and there we are. So at least when we see this, we know that you've done step 1 of your data analysis. So these are not sitting well. Maybe I could click on all of them, layout, and click middle so that we center. We could even put them at the top so that it looks a bit better. It's also important to label your tables, so I'll click there, and then I will click center so that the cursor is at the center, and I'll name that as table 1, and then I'll say sample profile, and I can make that bold. So you would go ahead and report your results like this. You want to comment about the age, the gender, and the marital status. And so here we say the largest group among the respondents consists of individuals between the age of 21 to 30 years old, accounting for 45.9%. So when you look at that, 45.9% is accounted for by individuals in that age group, which was the largest. Then following closely, individuals between the ages 31 to 40 years old make up 40% of the sample. So basically you just give a few of the age ranges, then the remaining age groups made up the rest of the sample. You then go ahead and talk about the gender. So a majority of the respondents were male, while females represented only 36% of the respondents, and you see that when you look at that. Okay, then finally you want to talk about the marital status. So here single individuals formed 52% of the sample, 52.9%. Married individuals accounted for 45.2% of the respondents. So basically in this section we have summarized the sample profile. Let's now go ahead and do the next section. The next section of the analysis is to do some validity and reliability tests, and we'll do a number of tests here. So we'll go back to SPSS. So while in SPSS we will begin by first going to first of all, you know, we have a number of variables. So we have TC1, F1 and FN1 and so on. We need to check if these variables actually load or are indeed measuring what they intend to measure and so on. So the first part we'll do is principal component analysis. So for that you go to analyze, go to dimension reduction and then factor. Then I'll change that to display variable names. I need these variables, so I'll pick them all up except the one we want to use, or maybe I could just go ahead and do it. So all of them, I'll pick them except our demographic variables. We've already accounted for those, so we'll drag those the other side. So I clicked and moved the other side. I'll check for descriptives. I think we'll just leave everything the way it is. For extraction, this one is important. Change this to, I think just leave that to principal components and let those be the way they are. Click continue. For rotation, we're going to use varimax rotation, and we'll leave the rest the way they are. For scores, we'll just leave it the way it is. And then for options, this is important, sort by size. Sort your options by size. We'll click continue, and then we're going to click OK. Once we click OK, SPSS will go ahead and do the analysis for us. It's running, it has run. Once it runs, the interpretation is as follows. So the variables that we have here are altogether able to explain 61.6% of the variance, and the variables we have are divided into 4 components. Indeed, in our study we had 4 components, and that's very important. If the 4 components can come out, then that's good. We had awareness, fairness, complexity and compliance, and this is showing that we have 4 components. So let's see those 4 components. Well, it's showing a mixture here, so it's telling us that we have all these variables. Actually, what we're interested in is the rotated component matrix. So we go to the rotated component matrix and we can just copy that. We can copy it, and once we copy it, I'll come here and paste it, rename that and say this will be principal component analysis. I'll just say PCA, and then I'm going to click there and paste them. So I can expand this for better view. I'm going to click all of them. Before I click on them, I'm going to just highlight. So component 1, you just start from the top. If you've picked the rotated component matrix, when you click on top, go all the way until you find values. So normally we want to pick values at 0.6 and above. So if I can go ahead and highlight them, these values are showing that this is made up of one component. As we can see here, that's TC, so that should be a component there. Then when we find that you have values going below 0.6, or anything below 0.6, sometimes 0.5, but 0.6 and above is recommended, you can then switch. So this is component number 2, and its factor loadings are above 0.5, 0.6, all the way to the bottom there. If we go there, it goes below 0.6. So this is the second component. The third component will start from here and we'll go all the way. We find 0.6, we stop, and then we go all the way and we find that, and then we stop. So this is showing that we have 3 components, and the components are loading appropriately on each other. This is an important table to present. In some cases, you're going to find that these components are actually not loading the way they should load, in which case we have to delete some of the components. But in this case, all the components have loaded appropriately, and I can see here this is CP. It's actually showing us that CP3 is stronger. The higher the value, the better, is stronger than CP1, and but then all these are showing that the components are loading appropriately. So I'm going to get this table, but I'm not just going to insert it the way it is. I have realized that the components TC1 and these are loading appropriately. I'm just going to copy it, all of it, and I'll create another tab here, and I'll rename this as let's include reliability analysis. So I'm going to paste it here, and I'm going to still go ahead and expand it as well. What I'm interested in here is I don't need that at the bottom, and maybe let me delete these 2 rows so that I haven't deleted any data. I'm just creating, I don't want those 2 columns. So here we are. So at the bottom here, I can even expand this. We're also interested in doing some reliability analysis. So let me go back to the article and show you what I'm trying to do. So when you go all the way to the bottom of the article, you find that they've presented some reliability, some factor loadings, but right at the bottom there are also these reliability tests. So to check the reliability tests, I'll actually use that. So we can just come here on the table and put Cronbach alpha. I think I'll just say Cronbach alpha for reliability test, and then I'm going to go all the way to that side. I'll start trying to present this in APA format. So I'm going to select everything, and I'm going to make everything like that, remove the borders, delete that, and then maybe I could even delete that, and then I'll just say component or variable, just say variable, and then I'm going to draw lines there, to draw some bold lines there and here, and then I'm going to draw one at the bottom here, and I'm going to draw one at the bottom here, and then I will undo that and select everything, then just change this to Times New Roman, enter, then 12, so that it looks big and nice. Then I'm going to, I know that these variables were all measuring TC, and TC from my data there is tax compliance, which is the variable, the outcome variable. So I'll insert a row there and just say tax compliance. Then FN was measuring tax fairness, so FN is tax fairness. So I'll come back here and enter tax fairness. And then I know that AW was measuring tax awareness. So I'll come here and enter tax awareness. Then I know that CP was measuring complexity, tax complexity, so tax complexity. Okay, I'll do that. Before I proceed here, actually before I label them, I actually needed to check the Cronbach alpha to check if these variables are reliable. If they are reliable, then the Cronbach alpha for each of them, tax complexity, which is component 1, tax fairness, component 2, each of them is going to have Cronbach alpha of above 0.8 is recommended, 0.6 is acceptable, so you need to refer to literature when accepting or rejecting. So let's go and do analysis for Cronbach alpha first. So to do our Cronbach alpha analysis, we go back to SPSS and we say analyze scale reliability analysis. I'm going to reduce that to display the labels. So what you want to do is come back to your factor analysis, look at the variables that seem to have loaded together. So I can see a TC1, 2, 3, 4, 5, and 6. Seems like TC1 to 6 loaded together. So I'll come back to the table and get TC1, 2, 3, 4, 5, and 6. So you pick the ones that loaded together and move them there. In terms of statistics, maybe we could check the item, we could check scale if deleted, and we'll click continue, then we'll say okay. So the analysis is still running. Once it completes running, we can check here. So here is the Cronbach alpha, 0.829, 6 items are included, and then this one is showing what will happen if we deleted one of the items. So you'll notice if we delete TC1, the Cronbach alpha will reduce to 807. Deleting means as we're doing that analysis, if we do not include TC1, but it will reduce instead of being 829. Then again we go all the way. If we delete TC2, it will reduce from 829 to 821. So we need to include all the 6 items. We need a high Cronbach alpha is good, so we can copy that. So we get 8.29, and we'll come and say for tax compliance the Cronbach alpha is 0.829. Okay, and we're okay. The next one is component 2, tax fairness. So here we can see it's FN 1, 2, 3, and 4. So going back again, I'll close that. I'll go to analyze, scale reliability. I just need to reset this, display variables, and that was FN1 all the way to FN4. Move this side, statistics, scale if deleted. Okay, check the variables. That's 0.879, and none of those is higher, so 0.879 is okay. 0.879. And then the next one is I think that was tax fairness. FN tax awareness is AW. So AW we have 1, 2, 3, 4, and 5. So same procedure. So just to check on tax fairness, if I come back here, okay, that's AW5, move, item, scale if deleted, continue, check, then that's 812, and here, take note of this one. So this is showing that if we deleted AW5, the Cronbach alpha will increase to 0.825, but currently it's 0.812. So we need to improve the reliability, and so I'm going to delete that AW5. So what I will do is I'll come back here, except if my reliability was really low, I could have deleted and redone the analysis. So what I could have done is I could have come back here and then done the analysis as analyze, dimension reduction, no, not dimension reduction, analyze, scale, reliability. Then I would have brought this back here, and then I would click OK to check the reliability. So 0.825 instead of the previous 0.812. But then I think it may also be an item of value, and it doesn't change my reliability so much. So I'm going to go back and I'm going to include it. So dimension reduction. But let's just see again. If you come here and you look at AW5, so it was actually pushing the factor loadings to close to 0.6, which is really low, but I think it's okay. So since the reliability was really okay, we'll still keep it there. So AW5, click, and so we'll use 8.12. so this is 0.812. The next one, or the last one, is CP tax complexity. It's 1, 2, 3, 4, and 5. So when I come here, I'm going to go ahead and pick analyze, factor, reliability analysis, reset this, display names, and I'm interested in CP. So CP 1 to 5. CP1, press shift, click downwards, then move all of them this side, check the item, scale if deleted, continue, click OK. The analysis will come, and that's 0.806, and if we delete them, no change, so we'll pick 0.806. so we can pick that and say 0.806. 0.806 confirmation. That's the way we do. So at least this can now be copied, and we can take it to our Word document. So we will copy it, and once it's copied, we can go ahead and go to our results section there, section 5.2. so after our sample profile, I'm going to paste here, and once I paste, I'm going to click there, auto fit to window, so that it fits the entire window. I'm going to then nicely say validity set table to validity and reliability tests, validity and reliability, can even make it bold, and there we are. So at least people can see here, and obviously here you can also give a description of what each and every one of these are. Like I know in this article what we did is there was also a section which was giving a description of each and every one of those. And then so by the time we were summarizing that, people already understood what each of those were. So when you come here, there you are, and the table looks really nice. Then you can describe the results and say table 2 shows the results of principal component analysis. 4 components were found and all the components had factor loadings of above 0.6. So when you come here, the board figures there are all above 0.6, then which is the recommended threshold by Tabachnik and Findel. If you cite a paper, go ahead and include it in your references, okay, to show that you've read the paper and you've actually confirmed. So regarding reliability, the Cronbach alpha, so the Cronbach alphas are these figures at the bottom. So the Cronbach alpha ranged from 0.86 to 0.879, which indicates good to excellent reliability. Higher values of Cronbach alpha suggest that the items within each construct are measuring the same underlying concept consistently, and this is according to Nunwali and Bernstein 1994, which you can also put in your references there. So when you do this, then even before you go and analyze your hypothesis, people become confident in what you're doing. They are confident that you have confirmed the validity and reliability of the results. I'm pretty happy of recent, some students have gone ahead and done this analysis, and once they find problems, they go ahead and correct them. That's beyond the scope of today, but at least hopefully if your results come out as they should, then this becomes good. If they don't come out properly, you can always get in touch. So we're now going to move ahead and go to the next part. Remember, we are trying to test the hypothesis. So in step 1, we have done the sample profile. In step 2, we've looked at the principal component analysis, and now as you can see, the variables that we have are a lot. So tax fairness is being measured by several questions, tax awareness is being measured by several questions, tax compliance is being measured by several questions, and so on. So what we now need to do is combine. Since we've confirmed that these 4 questions are a reliable measure of tax compliance, we need to combine them. The way you do that in Excel is, in SPSS, is to combine all these into one tax compliance variable. So to combine TC1 all the way to TC6 into tax compliance, we go into SPSS, and so we'll go and say transform, compute variable, and we want to compute tax compliance. So before I do that, let me cancel. I want to show you something. So there's no tax compliance here, we only have TC1 and whatnot, but then I can come here and say transform, compute variable, and I'll say tax compliance, and then tax underscore compliance. Remember, this doesn't accept spaces, so that's why I'm putting underscore compliance. And then what I want to do is I want to find one variable for tax compliance. I could find an average by saying mean. Then I'm going to click here, display variable names, and I'm interested in TC1 all the way to TC6. So I'm going to double click TC1, put a comma, it's appearing there. Once I click it, double click again, put a comma. You can even type it out, TC3, except put a comma. I think it's a bit too slow for me when I'm typing, so I double click, put a comma, double click, put a comma, and double click, and then close it. Once I do that, it's going to find the average of these, and it's going to name it as tax compliance. Take note of what happens on 27 there. So click OK. SPSS will analyze. It's done. I minimize that, and we have a variable TC tax compliance. When I come this side, I'm going to find the variable tax compliance, and it has been inserted there. I can do the same for the next variable. So the next variable, when I come to my results, is tax fairness. It's combining FN1 all the way to FN3. No, FN1, 2, 3, and 4. So when I go to SPSS, I just go to transform, compute variable, and I'm interested in, this is tax fairness. So I'll name this as tax fairness. And I'm interested in the mean. So it's the mean of FN1, FN2. Close the bracket and click OK. Once I click OK, you should pay attention to what happens there. So OK. And there we are. SPSS has done that. So this is just the output. It's showing us what has happened. You can always just close it. Then we'll go to the next variable. So I'll do the same for all the variables. So here we go. Okay, so now what we've done is we have combined CP1 to CP5 into tax complexity. We've combined AW1 to AW5 into tax awareness, and so on all the way to tax compliance. So we now have the 4 variables there, just like we had the 4 variables in our initial study. And now what we need to do is go ahead and calculate. So what we've done is we've created what are known as composite variables. These are a composition of various small different measures. So now we can work with these 4, and what we now need to do is carry out first step correlation analysis. So to understand how correlation and what correlation analysis is, so if you have H1, if hypothesis 1 is tax awareness has a relationship with tax compliance, then you're working with correlation analysis. Hypothesis 2, tax fairness has a relationship with tax compliance. So here you're looking at relationship between X and Y. But if your study is on effects and you're saying tax awareness has an effect on tax compliance, then you use regression. If you say tax complexity has an effect on tax compliance, then you use regression. So I'm going to go ahead with example 1, where you're doing analysis with relationships. So with analysis with relationships, we do correlation analysis, and the way we go about it is as follows. So you go back to your SPSS, then you go to analyze, correlate, we use bivariate, and we will then go all the way down to the variables we are working with, starting with the dependent variable. The dependent variable is tax compliance in this case, so we move it there. Then we can move the rest of them. Maybe I will put them in any order. Then in terms of options, I think I'll not get anything else. I'll leave it as it is, and then I'll just click OK. Before I click OK, so you can use Pearson correlation, Kindle correlation, Spearman correlation, a one-tailed or two-tailed. Whatever choices you make, you need to report. I'll leave it as default. I'll use Pearson so that we can report Pearson, and then I'll click flag significant correlations, then I'll click OK. Once the analysis goes ahead, so it's still running, once the analysis is complete, we will have this correlation table. Again, you don't just want to pick it up, you want to copy it, go to Excel, then I'll click there, and I'll say correlation. So then I'll paste my table, and then you're going to notice that what you have on the left hand side is also what you have on the right hand side. So if you look at this, we have correlation, we have tax compliance, compliance, fairness. So I could actually, and then you have unnecessary data. So what I tried to do is just remove unnecessary data like this. First of all, we already asked SPSS to flag significant correlation, so anywhere where there's a star, that's significant. I could increase this a bit. So anywhere where there's a star, that's significant. Where there are no stars, that's insignificant. So I'm just going to go ahead and delete the significance, and the ends. So I'll delete that. Actually there, so those two, I'll delete them. Then I'll come down here, the significant and n, I'll delete it. Even here, the significant and the n, I'll delete it. So you just make sure you don't delete important data. I'm just deleting the significance and the ends, so that's gone. Next, I'm going to then expand this a little bit. So compliance, I'm going to put 1, 2, 3, and 4 here, and from here you're going to notice that compliance is also compliance, which is 1, so I'll put a 1. Fairness is also fairness, which is a 2. Awareness is a 3 here, and then complexity is a 4, so we'll put a 4 there. This reduces the amount of work, because when we reduce it, it now looks like that. This Pearson is also not needed, so I could first of all here merge and center so that it's gone. Then I could click there and just delete so that it looks like that. This is now clear. I can remove the borders, then merge and center. I can delete that so that I now am able to draw nice borders like that, and like this, and then here, and escape. I can insert there so that it comes in the middle. I can do that, and then I'll save variable. This is tax compliance. This is tax fairness. This is tax awareness. This is tax complexity. Okay, and then as with all correlation tables, what you will notice is that this is showing the correlation between 2 and 1. which is 2.83. This is also showing the correlation between 2 and 1. So we are duplicating the data, so you can delete that. It's the same thing here. This is showing the correlation between 2 and 1, and this is showing the correlation between 2 and 1. So along the diagonal on top here, you can just delete the ones, and above the diagonal you can delete those because we don't need them. They're simply duplicating the data. Then we can copy this. I actually want to reduce the size of this because they go to the bottom. I think they can be 8, and then these can be increased to 12, and then we can select everything and change it to Times New Roman. Then we can copy this table and paste it in our results section there, and I'm going to name this section 5.3. I'll name it 5.3. so I'll come here and say 5.3 correlation analysis. So we'll come here and I'm going to go ahead and leave space for my description. Then I'll paste. No, I don't want to paste that. I want to copy this. And paste it here. There we go. Then I'm going to select it, right click, auto fit window, so that it fits the entire window. Maybe I could push it downwards, and there you go, a nice correlation analysis table. And then I'll paste there, center, and say table 3.1 correlation analysis, and there you go. Then we can go ahead and interpret the results. So once we present those results there, we can then go ahead and say, so the results of table, this is table 3.1. Please notice how if this is chapter 5, you want to name this as table 5.1. So 5.1, and then you want to say this is table 5.1, shows blah blah blah. Also, this is the next one is table 2, so this will be 5.2, and you say according to table 5.2. Then finally the next one is table, the results of table 5.3 indicates the correlation coefficients between the different variables. Okay, so tax compliance, tax fairness, tax awareness, and tax complexity. So it's showing the correlations amongst these variables. The correlations are as follows. So we're interested in how the different, component 1 is tax compliance, so we're interested in this one. So tax fairness has a correlation of 2.83 with tax compliance. Tax awareness has a correlation, and these are positive, has a positive correlation of 2.46. This is a weak correlation, so you could use some literature, or you could simply refer to some logic. So basically between 0 to 3, you could say weak correlations. Moderate correlations between maybe 0.4 to 0.5 or so, and then higher correlations would be as you get close to 1. So here we go. So in terms of the correlations, we can say tax fairness is positively and significantly correlated with tax compliance. So you can see here tax fairness has a positive and correlation, and it's significant. It's positive because there's no minus, so it's positive, and there's a star, which means it's significant. So tax fairness is positively and significantly correlated with tax compliance. It's a good idea to put the R value there, so R equals to 0.3, and when it's significant with, remember the stars at the bottom here are signifying how significant it is, so that's why we have that level of significance. So this suggests that individuals who perceive tax system to be fair are more likely to comply with the tax regulations. So the higher the fairness, the more the higher the fair, because it's positive, so the higher the tax fairness, the more the tax compliance. Then the next one is tax awareness. So tax awareness is this one. It's also got a positive correlation, and it's significant at the 0.01% level. So what we'll say is tax awareness also shows a positive and significant correlation with tax compliance. R is 0.26 and P is below 0.06. So this implies that individuals with higher tax awareness, so the more the tax awareness, such as understanding of tax responsibilities and obligations, these are more likely to comply with tax regulations. Take note of this one, however, tax complexity has a negative significant correlation. What can we say? So tax complexity, on the other hand, exhibits a negative significant correlation with tax compliance. R is minus 0.029 and P is below 0.09. Okay, so we get the P from here with 2 stars. It means it's below 0.09. And remember, we got this from SPSS. What does this mean? The higher the tax complexity, that negative figure means the lower the tax compliance. And this is what it says. So this suggests that perceived complexity of tax system increases individuals may, so it says suggests that as the perceived complexity of tax system increases, individuals may experience difficulty in understanding and complying with regulations. So higher levels of complexity might lead to confusion and therefore reduced compliance behavior. And these results are making sense. We are getting them from the analysis. Now, if you were doing correlation analysis, which is to find the relationship between X and Y, these results would be enough. You have analyzed the relationship between, so H1 is supported because, why is H1 supported? Because if you come up here, because of this, the results are statistically significant. If the results were not statistically significant, then those stars were not going to be there. The p-value was not going to be less than, and in that case H1 was not going to be supported. So you could also talk about your hypothesis as you go into the hypothesis section. If H2 is not supported, the same would be the case. So we've done some basic correlation analysis. I'm now going to go ahead and do some regression analysis, which is where you're trying to assess the effect of X and Y. I'm highlighting again that what we are doing is just basic analysis, and there are a few things, considerations that I've left out, but at least if we can see some of these things in your dissertation, then we are likely to give you a pass mark if we are an examiner, especially for undergraduate. But worse, we are seeing postgraduate students also leaving out much of this analysis. So with regression analysis, what you want to do is, I've copied that and I'm going to name this as 5.4, and I'm going to call this regression analysis. And with regression analysis, what you do is you go back to your table. So I'm going to close this. I'm just going to do very simple basic regression analysis to check the relationship, or I mean the effect of each of these on that one. So to do that, I'll just go analyze, regression, linear, and then display variables, and I'm interested in those variables. So the dependent variable is tax compliance. I'll click there and bring it there. The independent variables are tax fairness, tax awareness, so tax fairness, tax awareness, and tax complexity. So we've brought those there. And then I'm just going to, you could get some statistics. We need the estimates, so please do include them. Model fit, R and R squared, you know, all these, when you tick them you need to report them, but maybe I'm not going to tick anything there. Plots, you could have all those plots, they are very useful. You could have an histogram to check what's happening, normality and whatnot. There are a lot of assumptions we test in linear regression, but I'm not going to do all of them. I'll just do the histogram plot there. Then in terms of options, usually this is important if you have missing data, but I'm not going to click anything there because we didn't have any missing data. Bootstrap, I'm also not going to do anything there. So you could just go through there and see what to do, but basically I haven't changed anything. I'm not going to use any of these options as well because I'm just doing basic analysis to check how each of these is relating to those. So when I click OK, SPSS will go ahead and it will do the analysis for me. So it's still running the regression. Once it's completed, we can see here the results of the regression test. It's shown us the model the model fit there, results of a model fit. But for your interpretation, you could spend time there to make sense of each of these. They're important, especially for convincing people that your model is a really good model and the like. But the main results we're interested in are these ones. Okay, so this shows the beta values and the standard errors, and then it also shows the standardized beta values, the t values, and the significance. So usually that significance is showing us whether each of these has an effect on the outcome variable. So tax fairness, when you look at the p-value there, if the p-value is below 0.05, then it has a significant effect on tax compliance. Then there, this is not below 0.05, it does not have a significant effect. This does not have a significant effect at the 0.05 level because this is above 0.05. So let's just see how we interpret that. So I'm just going to copy that. And once it's copied, I can come here and say regression, then I can paste this. Maybe just try and convert it to APA format a bit, and maybe do that. Draw a line there, there, skip, delete this, Times New Roman 12, so tax fairness, tax awareness, and tax complexity. Maybe we could copy this and paste it in the document. to, I think there was something that needs to be done, so I'll copy it like this. Then I click there, fit to window, and there. Okay, not really perfect, but at least you get the idea. Okay, get the idea. Could make this center. Okay, so when interpreting if something is significant, we look at the significant values there. If they are below 0.05, 0.05, then it's significant. So I'm going to just show you, these are the results, and then I'll scroll up to show you how you could write them. This is how you could write them, the regression results. You can read through, and you can pause, read through, and once you do that, then you're okay. So to see if you've done a good job in this chapter, just make sure that you please do the sample profile, do the validity and reliability in the tables there, do the correlation analysis, and then do the regression analysis. Let's also label this table. So this should be table 5. I think this was 5.2, so this should be 5.3. This should be table 5.4. Or let's just say regression results. Okay, finally, once you're done with that, you then want to tell your respondent, your audience, what the results of hypothesis testing were. So in our case we have H1, so let's say I have H1, H2, H3, and H1 was that so for each variable I have awareness, fairness, complexity. So tax awareness, tax fairness, tax complexity. So tax awareness has a relationship. If your hypothesis has a relationship, I'll copy this, control copy, has a relationship with tax compliance. And the second one is tax fairness has a relationship with tax compliance. Tax complexity has a relationship with tax compliance. So you need to state whether, so hypothesis I can merge these and center them, and then supported, was it supported or not? So the first hypothesis is to do with relationship. To check this, we can check the correlation analysis. We can see that tax fairness had a significant relationship, and so when we go there, this is supported. Again, I started with tax fairness. Okay, tax fairness. Actually, tax fairness, tax awareness, tax complexity all have a significant relationship, and so we can say supported, supported, supported. But if you have hypothesis like this, I'm going to copy this and I'm going to put it here. So it says tax awareness has an effect on, or let's just say tax awareness, yeah, okay, has an effect or affects on tax compliance. Okay, so let's expand that. Tax awareness has an effect on tax compliance, tax fairness, tax fairness has an effect on tax compliance, and tax complexity has an effect on tax compliance. So if you have effect, then you're not going to look at your regression table. You are not going to look at your correlation table. For effects, you look at your regression table. Now, when you look at your regression table, what you're going to notice is on the regression table, effects are here. So here, this is smaller than 0.05. So this is supported. So tax fairness is supported. So tax fairness is supported. Let's delete this. When you come here, this is above 0.05. That is 0.121. It's above 0.05, so it is not supported. So for tax awareness, we are going to say not supported. And then finally, for tax complexity as well, this was almost 0.05, so not supported because it's above 0.05, so say not supported. So you need to get this now, and depending on the analysis you're doing, if you were checking for effects, you could get this one. If you're checking for relationships, you could get this one. So if you're checking for relationships, you get this one, and you need to paste it in your hypothesis testing section there, and then just make it neat, auto fit to window, and then you comment on these and say hypothesis so and so was supported, and hypothesis so and so was not supported. So this is basically what you do. We expect to see these tables in your document. Let's just put this down there. Let's say this is table 5.5. So we expect to see 5 tables minimum in your work, and this is going to be a hypothesis. We expect to see 5 tables with proper references, and if we do not see those 5 tables, usually it's a problem. Depending on what analysis you're doing, we raise a lot of questions. So I'm hoping that for those students sitting in the class that I'm handling and those that I'm supervising, I'm hoping that your chapter 5 is going to look something like what we have right now. Thank you. If you have any questions, please do feel free to reach out.